happy to be here. Okay, thank you. So I'm so happy to be here to report my study. And according to the Bola, there are three modes of Western thought. The one is the supernatural or the transcendental, which treat human as a part of divine creation. The second one is natural or the scientific one, views humans as a part of natural order. The third one is humanistic, which is the role of the Renaissance. It emphasized humans' experience as the starting point for establishing knowledge. And Italian Renaissance is one of my favorite because the era of the Renaissance in Europe has been viewed as a critical turning point between the Eastern and Western culture. And according to Burckhardt, the Italian Renaissance, it flourished individualism and the competition for fame radically transformed science, the arts, and politics. According to Boas, because the scientific ideas and achievement of the Renaissance period was absolutely crucial to sparking the scientific revolution, because they attempt to discover and relearn what the Greeks had known dominated men's minds in 1450s. The brilliant innovation has surprising implications. So I use the period of the Renaissance as one of my teaching strategies for teaching STEAM to my students, because mathematics and science has long been viewed as a tool, and its relationship between the culture had been neglected in our school curriculum. So in my class, which is a liberal arts course entitled Sciences and Arts during the era of the Renaissance, in this course, I'm going to offer my students, let them to know, to realize the role of mathematics and science throughout human civilization, especially during the Renaissance. And I have two research questions. The first one is, in what way and to what extent college students in Taiwan may reevaluate the correlation between science, technology, engineering, arts, and mathematics as they experience the STEAM liberal art course? And the second one is there any difference between students' views on science, technology, and society before and after a STEAM liberal arts course? I have three instruments. The first one is the pentagram scale. This scale measures students' views about the difference of their evaluation between STEAM before and after course. The second one is students' reflection notes. They write down their thinking in the class at the time to express their thoughts about the topics in my material. The third one is VOSTS, which is developed by Aikenhead. It is a semi-open questionnaire employed to investigate students' views on science, technology, and society. But the analysis is still in processing, so I'm not going to report the result of this part today. This is my course outline. Humanism and social background of the medieval age and Renaissance, mathematical ratio and perspective in the Renaissance arts and science of Leonardo da Vinci, physics and astronomy during the Renaissance, Pythagorean interval, and 12-tone equal temperament. And in my class, there are three activities. The first one is making Leo da Vinci's parachute. The second one is students, they have to explore the relationship between mathematics and art. The third one is they have to explore the relationship between mathematics and music. So I'm give you some highlights about my class. In my class, I introduced Kepler's models. This is Kepler's astronomical models. You can see that the model is very beautiful. And the the 6 planets, their rotation was divided by 5 solids, the so-called Platonic solids. It's very beautiful. But it's not true. But Kepler does not make the model based on nothing. He seriously do the calculation to compare the ratio of outer sphere and inner sphere for each solid, and the ratio of relative distance between each planet. You can see from this data. Among the 5 data, there is only one is not so similar, and that is the ratio between Earth and the ratio between the Mars and Earth, which is 1 and 0.66, but the dodecahedron is 1 and 0.795. So there is only one exception. So this makes Kepler think that, okay, the God created the whole world according to mathematics. And the only exception, probably due to the measurement error. So at that time, he believed that his model is correct. Of course, Kepler realized that the model is wrong many years later. And this is Galileo experiment, because before Galileo, Aristotle said that the speed of the free-falling body is always the same, but Galileo didn't think so. So he made an experiment to test his idea. In this inclined plane experiment, he realized that the speed of free-falling body is not always the same, because the speed is in the ratio is proportional to the square of the time. So in my class, I asked a carpenter to make an inclined plane. The angle can be changed. So we can see the slow motion. This is a 30 degree. Okay. And this is 45, oops, sorry. This is 45 degree. Oops. And this is 60 degree. Okay. After watching this video, I show them the data. Okay, I record some data. The left one is the time, and the second one is distance. Let's explain. And the red ones, first order difference. You just minus the second one to the first one, you get the 3.2, which is first order difference. And this second order difference, you minus 5.3 from 3.2, you got 2.1, and so on. So you can get third order difference. This data is for 30 degree, and this is for 45 degree, and this is for 60 degree. So after showing the data, I asked students, what can you see any pattern from this kind of data? In the beginning, they just don't know how to read this data. So I spent about 20 minutes in my class for students to do observation. And then I asked them, if they have no any idea, I asked them to focus on the red one, the green one, and the blue one. And I asked them, is there any pattern among the red one? They say, okay, the red one, the data in the red one is getting larger and larger. Yes. How about the green one? They have no idea. How about the blue one? They have no idea. So I show them, I asked them to compare the different data between 30 degree, 45 degree, and 60 degree. Some students found that, oh yes, the data of green is getting larger and larger. For example, in 30 degree, it is about 2. Some is 1.9 and some is 2.3, but it's about 2. And the 45 degree is about 5, and 60 degree is about 9. So I asked them, what does that mean? They have no idea. And then Let's look at the blue ones. This blue one is very small, about 0. Yes. How about this? Yes, it is all about 0. It's also about 0. What does that mean? They don't know about that. Of course, as my interpretation, they have no idea about the pattern of this data. And then I show them, okay, you have learned this formula in your high school. It is a formula for free falling bodies. Okay, they know the S equal to 1/2 GT square in their physics class, and then they learn differentiation in their calculus class. So they know the differentiation of S with respect to T is GT, and the second order of differentiation is G, and third order of differential is 0. And then I ask them to compare, okay, with the green one and the blue ones. And they realize that, okay, the second order difference is very similar to the second order of differentiation. And the third order difference is very similar to the third order of differentiation. So because the second order of differentiation is different, and the calculus is continuous. The one is discrete, and the other one is continuous. So they can compare this formula with that data that I provided for them. And it's about the painting. This is Leonardo da Vinci's famous painting, Bridge of the Man. And as we can see that it is all about mathematics. There are a lot of ratio here. I'm not going to explain in detail. And there's a golden ratio. And this is about the perspective theory in Renaissance painting. The theory of perspective painting is developed by the Alberti. And we also can see this famous painting, Last Supper, and it satisfies the theory of perspective. And if you draw a yellow line, yellow dash line between the window behind the Jesus, you can see the ratio is golden ratio again. Okay. And in my class, this is the spiral of square root. And I asked the students to do origami to make this spiral in my class. After they make the spiral of square root, I asked them to do some decoration. Okay, so we can see the spiral. And the spiral of this man, you can see that his belly is very big. And the spiral became this woman's head. We can see they are so creative, right? And this is another famous painting of the Renaissance, Raphael's The School of Athens. There are a lot of mathematics, scientists, and philosophers in this painting. So I introduced many persons in this painting, but I just report the Pythagoras, who is on the left corner. He's writing something and discussing something with others. So what are they discussing? From this blackboard, we see that they are discussing about the music. There are 4 numbers, 6, 8, 9, 12. This is very important for numbers for Pythagoras to create his musical scale. And so before that, I asked students to do some kind of experiment. And then I just, following the experiment, I just explained the mathematical reason for them. And we can see.
2, 3, go!
Okay, so after that, they realized there's a relationship between mathematics and music. And this is Leonardo da Vinci's painting in the Codex Italics. The Da Vinci's parachute is an unusual pyramid shape. And in his note, he wrote that if a man has a structure made out of coated pearls, 12 arms wide and 12 tall, he was able to throw himself from any great height without hurting himself. So I asked students to copy Da Vinci's parachute. Before that, they have to do some kind of analysis, mathematics and physical analysis. Let's see how well did they do. Yeah. So the second one is successful. Okay, that is about the result. In the beginning, students have to write down their value, their score about the correlation among science, technology, mathematics, engineering, and art. We can see that the scores are very high between technology, science, and mathematics and engineering. But the score is very low between mathematics and art, science and art, technology and art, and engineering and art. After the class, we can see that the score between math, science, technology, engineering, and arts are increased. 3 of them are significant, but the pot score of technology and arts is almost significant. This is statistic result. So we can see the TA, the technology and art is almost significant. And this is some responses from students' notes. One of students said that are the similarity between nature and mathematics a constant or law? It deserves rethinking. I learned golden spiral, rectangle, and ratio in this class. Next time, I will pay more attention to whether the golden ratio is hidden in the painting. Then another student said, today's topic is mathematics and music. It makes me feel weird. There's a feeling like this. People build musical scales to help silent numbers make their sounds. I love this statement. So in my class, I'm not going to show student answers because it is a liberal art course. So I'm not going to show them the answers. I asked many questions in my class. Why didn't such a cultural root, including mathematization of science and the use of mathematics in arts, did not appear in the Eastern civilizations? And is the Western mode of scientific development the only possible paradigm? Because especially in China, the ancient China, the scientific development involves little mathematics in their development. The third one, what should science look like without mathematics? And I asked them, if without mathematics, how do science look like? Some students said, would be no science without mathematics. And some students say, yes, still have science, but just doesn't look like as we see today. But they don't know how do they look like without mathematics. So in my class, that's my intention. More questions than answers are provided. So I just said I'm not going to show them the answer. Answer isn't important. You can Google or ask ChatGPT. You can get any answers. But question is very critical for their thinking. Thank you very much.